Alright, let's go over this problem. In this question, we asked to use this spherical coordinate to iterate the triple integral, where E is a solid region that lies inside the sphere x squared plus y squared plus x minus 3 all squared equals 9, and below the cone z equals square root of x squared plus y squared. So here we are to write a description of the solid E in terms of the inequality involving the spherical coordinates. We are asked not to evaluate the integral. Okay, that's really nice. All we want to do is just to figure out the bounds. Okay, so let's do that. Now, first of all, let's see how the region looks like. Well, here we're given cone z equals square root of x squared plus y squared. So let's say this is Cartesian coordinates. So I'm just using this to explain how the region would look like. So here we're given z equals square root of x squared plus y squared. Well, the idea is that if you think about the values for z, let's say this is my x-axis, this is my y-axis, and this is my z-axis. Okay, you can think about it like this. For every values of z, let's say z is 0, of course, this is going to be just the value for, this is just going to be a dot on the xy plane. Okay, and then for, let's say if z is 1, right, that means on the xy plane, this is going to be a circle of radius 1 on the xy plane. And z equals 1 means that you would have a circle that is parallel to the xy plane, but then it is constant at the value of z is just 1. So you have a plane that is parallel to the xy plane. Plane z equals 1 that is parallel to the xy plane. But then if you project it on the xy plane, you're going to have a circle. You're going to have a circle of radius 1. So that's the idea. Then if z is 2, again, you have a plane of z equals 2, right? If you project that plane on the xy plane, you will have a circle. So it's more or less like this, level curves. Then that's the radius corresponds to the value of z. How would that look like in setting? Basically, you're going to have something like this. Okay, so you can think about this. That let's say this is z equals 1, this is z equals 2, this is z equals 3, and all the way up like that, because the radius has to increase with respect to the point in your z-axis. Yeah. Okay, nice. And now let's go forward. Okay, now next thing is to draw the sphere. So here, if you look at the sphere, here we're given this equation of the sphere to be x squared plus y squared plus x minus z minus 3 all squared equals 9. Okay, nice. So the point here is this: if your x squared plus y squared, if we're given x squared plus y squared plus z squared equals 9, that means that the center of the sphere is at 0, 0, 0. But since this is shifted by, since z is z minus 3, that means you are shifting the sphere by 3 units up, okay, from transformation of graphs. So if you want to shift any axis, all you have to do is just to add, subtract from that axis. So if this was z plus 3, that means you need to shift it down by 3 units. Okay, but this is z minus 3, that means we have to shift it up units by 3. Shift it in the z direction by 3, positive z direction by 3 units. Okay, so let's say this is the center of the sphere, which is 0, 0, 3. Okay, then the sphere has radius 3. So basically, the maximum height, or thinking about this from the reference point, that means the maximum height of the sphere is going to be 6. Okay, so let's try to draw our sphere. So basically we have this. So let's say this is our sphere here. Okay, so we have the sphere and we have the cone. So the cone is this. We have the cone. Because the sphere and the cone will intersect at one point. So we have the sphere and we also have the cone. So this is the cone part here. And this is the sphere part here. Okay, nice. All right, so if you look at the question, the region of E here it lies inside the sphere. So basically everything inside the sphere. And then below the cone, right? So below the cone. So everything below the cone. So basically if this is the cone, right? So everything below the cone is going to be everything here. Everything out here. Okay, so we have to be careful here in order to know how to interpret this problem. This is my cone, right? And this is the spherical part of the cone. Oh, not yet. That's not what I want. So this is the spherical part of the cone. And then, like, because we are looking at everything below the cone, so basically we are looking at everything outside. So I will actually draw that in red. So this is what I'm trying to do. Okay, so let me see. I'm actually trying to get it. Yeah, okay, so I think this is fair enough. And then I can take this out. Okay, nice. I can also take this out. Right. So this is what I'm looking at. Now, I understand that this is not perfectly fair. This is not perfectly what I'm trying to represent, but I just sort of hope that we sort of have like, an idea of what we're trying to do here. So what we're trying to do here is to actually calculate this region here, the volume, or let me say, we want to iterate over this region over here. Okay, outside the outside of, inside and below the cone. So this is exactly what we are looking at. Okay, so this is what we want to iterate over. Okay, so this is the region we are looking at. Again, because the problem says inside the sphere and below the cone. So everything below the cone is what we are looking at. All right, so with this picture, we should be able to now write our region outside. Okay, so what I'm going to do is that I'm going to draw my z-axis, and then this is my x-axis, this is my y-axis, and this is my z-axis. All right, so since the problem says we should use a spherical coordinate, and you remember that for we to use a spherical coordinate, we need three things. We need the radius, which is the rho. We need the phi, and then we need the theta. So okay, so what are all these parameters? So basically, for us to draw a sphere, we need three things. We need the angle, we need the radius, which is our rho. We need the this is the x-axis, this is the y-axis, and this is the z-axis. So this is my rho, which just tells me the radius to any part of the sphere, to any point in the sphere. Then the angle shows that, okay, I need to move an angle of theta right around this, around the plane x-y axis. Okay, you can think about it as you're moving around the equator. And then we also have the last angle here, which is my which is sort of my phi, which is the angle that makes with the positive z-axis. Okay, so we can think about this, because for me to really draw a sphere, first of all, I need to know, let's say this is my center, here. I need to know this angle here, right? This is the angle phi here. And then, of course, I know my radius. Then I need to really, I need to really move this flap here about the circle, right? I really need to move about a circle to really generate a sphere. Okay, so you can think about it this way. Let's say this is my center, for example. Okay, let me use this diagram over here. Let's say this is my center. I need to move and I need to move an angle theta just to, sorry. So let's say this is my center over here. So let's say this is my center over here, right? So I need an angle phi, which is more or less like, I'm just trying to figure out, let's say this is my center. I need to figure out this angle here, phi. And then let's say angle is between 0 and pi. So basically I move from the positive z-axis all the way to negative z-axis. So that's my phi. Now that we know all of those things, again we also need our dv rather, which is just rho square sine phi d rho d theta d phi. Okay, yeah. So that's the idea. Now, from our problem over here, we really need to figure out what to be the range for rho, what to be the range for phi, and what to be the range for theta. Well, the easiest one we can figure out here is our theta, okay? Because again, in this problem here, this is the origin here. Of course, this is the center of the sphere, but for us to use the spherical coordinate, we take the reference point, which is the origin here, to be our reference point for the spherical coordinates. Okay, so this is what we have. Okay, so imagine that we want to really figure out this region. So we want to generate this region over here. So basically, we want to have a rule that can generate all the way from here to this point here. So this angle from here to this point over here. Nice. Okay, and then we also need to figure out what to be our radius. Basically, we can figure out our radius from here, and our radius is going to be changing with respect to the angle. So this is the angle over here, right? So this is my angle phi over here, because you can think about this as my phi. Okay, and the radius is going to be changing with respect to the phi, because I need to generate all this side over here. Okay, of course at this point my radius is going to be 0. Okay, nice. Now the way to think about this is this. Like I said, the easiest one we can easily calculate is our theta, because for us to really generate anything that has to do with a sphere or even a cylinder, we need to move our angle theta to be between 0 and 2 pi. Okay, because the angle in a circle is 2 pi. Okay, because we really need to move all the way from 0 to 360 for us to really generate the solid. Okay, to really generate a solid, we can take a plane, then you rotate it about this axis, about the z-axis, then we can generate a solid. So that's the idea. So, but the next thing we need to figure out is what should be the bound for rho and what should be the bound for phi. Okay, well, to figure out the bound for phi, what we need to do is this. Since, again, I'm going to draw some, like how our phi really moves. So again, this is our phi. Our phi is the angle that makes with the positive z-axis. So we really want to move. So we really want to move from the z-axis. So it goes all the way down like this, right? So basically, because that's the way if you are to take like this to be your radius, this is going to be a bigger sphere. It's going to generate, if you are taking this as your reference point. Again, we are not making this as our reference point, but we are making this as our reference point to the sphere, to reference point to the given sphere. This is our given sphere, but we are making this as our reference point. So that means radius is going to be really, really big, right? Really, really big for us to generate, for us to move, traverse this path here. Okay, now why am I drawing that? You're going to see in a couple of minutes now why I had to draw this. Why I had to draw this angle. Okay. One thing I want you to keep in mind is that even though you are moving in this direction, your radius could still be changing, right? Your radius could still be changing. So even though you are moving in this direction, this angle here, your radius could still be changing. Yeah, okay. So now let's figure out the bounds for phi. So let's think about it before we even derive it. So basically the bound for phi would be between this line here and this line here, right? Because we want to figure out this region. So basically we are moving from this line here all the way to this line here, all the way to this line here. So let's try to figure out the bound right now. Now let's look at the relationship between Cartesian and spherical. So we know that x equals rho sine phi cos theta, and then y equals to rho sine phi sine theta, and then we also have z to be equals to rho cos phi. Okay, nice. All right, so again let's look at this. If our line is here, like if this is of course, for us to generate this, for us to traverse this path, we need to move from this line here down this line here. Of course, what does this equation represent? Of course, this is the path of a cone, which is just z equals to square root of x squared plus y squared. Of course, we have z to be equals to rho cos theta, or cos phi, sorry. Then this is x squared, which is rho square sine square phi cos square theta, then plus rho square. I'm just substituting this expression here. Okay, so here this is going to be rho sine square phi sine theta, sine square theta rather. And then if you simplify this expression, what do you have? You have rho square sine square phi. Why? Because cos theta plus sine square theta is 1, so I can just have that expression over there. Okay, nice. Then if I take the square root, I'm going to be left with rho sine phi. Then here on the left hand side I have rho cos phi. Because rho can cancel rho, and I can divide both sides by rho cos phi. So on this side I'm going to be left with 1, and on this side I'm going to be left with 10 phi. So which implies that my phi is going to be pi over 4. Okay, so meaning that the angle here can go here and then say, okay, fine. The angle here is going to be from this point to this point, it's going to be pi over 4. So this is going to be pi over 4. So let me put that in red. This is pi over 4. Because we are moving in a clockwise direction. Okay, from the z-axis, we are moving in a clockwise direction. All right, so we have pi over 4 here. And then you can sort of guess this angle here, because this is between this z-axis here and then y-axis here. This is because we are using the rectangular system. So the angle between your z-axis and your y-axis is pi over 2, which is just like 90 degrees, right? Because we are assuming that we are taking this to be orthogonal. Of course, they have to be orthogonal since it's since we are using the usual reference frame. So this is going to be let's say this is going to be 90 degrees, so which is same thing as pi over 2. So basically we are moving from pi over 4 to So we move from pi over 4 to pi over 2. Okay. So we can now have a feeling of what our phi is going to look like. So it's going to move from pi over 4 to pi over 2. Okay, so that's what I really want to explain. Okay, now the next thing is to figure out what will be the bound for rho. Again, you remember that I said that rho has to change because rho is not constant. Yeah, because you can see that if you are to move from here to here, right? If you can think of rho this way, so this is how our radius traverse in this case. So your radius is traversing here, right? It's moving all the way from here, right, to the lowest point here, which is going to be 0, because at this point here it's just going to be 0. Radius is going to be 0 at this point here, because there is no radius. You can think about radius at the origin is 0, so we know that this is going to be between 0 and some values, okay? Because your radius grows from 0 to any part of the sphere, right? So it goes from 0 to what point? So we need to figure out what equation describes this part here. What equation describes this part here? And to really figure out is not that difficult, because which equation are we going to use? We are just going to use this equation, because this is the equation of the sphere part here we are trying to traverse, right? So here we can just use all this expression over here to write this expression out here. So what are we going to have? So we have x squared, which is going to be rho square sine square phi cos theta, right? And then I think let me do this down here. Okay, so again we have x squared plus y squared plus z squared, z minus 3 square to be equals to 9. If I expand this is x squared plus y squared plus z squared minus 6z plus 9 equals 9. This expression here is the equation for rho square. And then this is going to be 6z. Now you know that z is given by 6. This is going to be 6 rho cos phi. Then we can reduce this to be rho to be equal to 6 cos phi. So that means the equation describing this path here is going to be from 0 to what? So it goes from 0 to 6 cos phi. Okay, nice. So basically, so what will be the region of this problem? So we can now write the region of this problem to be E, which is just between r, theta, and phi. It's going to be between, so your r first, this should be rho. I often confused it with polar, but we can keep it as rho. Yeah, so here we have 0 between, the radius is going to be between 0 and 6 cos phi. Your theta is most likely going to be between 0 and 2 pi. We've seen that. And then your phi is going to be between pi over 4 and pi over 2. Okay. See, the way to understand this is just to really look at what is really happening from the diagram. And I hope you guys understand what I'm trying to describe in this problem. All right. Thank you so much. Have a nice day.